Hello friends, this is Jay Brains. Welcome back to Fundamentals of Test-Driven Development and Evolutionary Design and High Discipline Programming. Today we're going to start with one of my favorite demonstrations, what I like to call architecture without trying. And so last time I discussed the point of sale system example. This is the exercise that we're going to do an awful lot of work on in this course. And during the introduction I described to you the sell one item feature, where we scan a barcode with a barcode scanner, and that barcode comes into our system as a string, and our job is, our very first job, micro job, if you want to call it that, is to display the price for that product on a text display. Now that'll eventually show up on an LCD, but for now, it's probably good enough if we simply model this as a text display. Now I'm going to work in Java for this version, so adapt the ideas to your language. If you're working in an object-oriented or object-based language, then the principles should work just fine. And if you're working in a functional language, then I think the only difference will be the way that we organize the functions. So I have already set up an empty project. I've installed JUnit and Hamcrest, so we can take a look over here. I have JUnit and Hamcrest installed here, and in fact, if I go and I look for a class called Matchers, I can see that I can find the Hamcrest and JUnit stuff. So we know for sure that we've got stuff installed. Now, of course, before I get started, I need to make test lists. So I'll flip over to my test list here and let's start figuring out what we need. The output for our test is the price that corresponds to the product we've scanned. And the input is a barcode. So what are the different cases we need to worry about? Well, the first thing I can think of is the case where the product that we've scanned, the barcode, is found, that we have a price for that barcode. Now, of course, if that's the happy path, that's the path where, you scan 1, 2, 3, 4, 5, you get $7.95. That's the correct price for the barcode. Everyone's happy. Ask my customer for $7.95 and off we go. Of course, if it's possible for the product to be found, then probably we have to worry about the case where the product is not found. And in that case, what I'd like to do is to display a message that says that, that product is not found. Something that makes it a little bit more obvious to whoever's using the barcode, whoever's scanning the product, that something went wrong. And we'll look at that in a little bit more detail in a bit. Now, some other possibilities that we might need to worry about, one of them is what happens if we have an invalid barcode. So this is a barcode where the format is wrong. If you take a look at the UPC, the Universal Price Code on a product, you can see that there's usually I think a 12-digit number. And that probably corresponds to some format where one of those digits is a checksum digit and all that kind of stuff. I'm not worried about that for this particular example. If all I need to worry about for now is finding the price for a barcode, then I can't really tell the difference between an invalid barcode and a product for which we don't have a price in our system. So I don't think there's any other way that a barcode could really be invalid. I suppose it could be empty. It could be the empty string, which is an interesting possible kind of invalid. And it could be null. We would be remiss if we didn't have to deal with the billion-dollar mistake of null. So I'm trying to think if there are any other examples, any other possibilities that would be useful or that we might need to worry about, and I can't think of one off the top of my head. So I think my test list is done. We have product found, product not found, empty barcode, and null barcode. And I think that's more than enough to get started. Of course, if stuff comes up as we go along, I'll have my trusty test list over here on the side. I'll be able to jot stuff down as I need to. All right, so I think we have enough to get started. So, as always, let's start with a test. So let's go down to our test source and let's create a new class. We're going to call the system point of sale, POS. And I don't really know what area of the system we're building, so I'm going to just start with my tests at the top level of the project. And we'll create sub-packages as it becomes more clear what we're building, what the pieces are, how they're going to separate from each other. Now remember, I don't like to name my test case classes after the thing I'm testing. I like to name it after the behavior I'm implementing. And this feature, we've been kind of talking about it as sell one item. So I'd say sell one item test is probably a good name. Now, one of the things that you'll notice right away is that I'm not writing any cucumber or selenium or any of these other kinds of tests. This is an intentional choice. I am not worried about it for now. For this particular exercise, if we write all the tests in JUnit and treat them all as code level tests, these start out being end-to-end tests anyway. So, cell 1 item tests. Let's run our tests and make sure that that we can run them. I should have set up the I probably should have set this up before I started the video, but you know, occasionally I get this stuff wrong. So what happens when why didn't that work? Let's create one for JUnit. There we are. So run all tests. Everything looks good. Let's run all tests and see what happens. And that appears to have done nothing. So I, again, tried to do the all-in project and I couldn't get that to work. So we'll try it now with all-in package. And now, yes, at the bottom we see no tests. So let's get out of the pinned and docked mode. Let's go back to our nice floating view. And let's run the tests. And there are no tests. Perfect. So now let's write our first test. What happens if the product is found? Now, as always, we're going to write the test from the assertion first. And if we go back to our diagram of the system, remember that the output is a text display. So the easiest way I can think of there are other ways to do this, but one straightforward way I can think to model this is a display object with a text property that I can read in our tests. So let's try that. Assert equals $7.95 display dot get text. And again, I'm just using the Java naming convention. If you want, in other languages, this would just be a readable property. If you wanted to make this a field, that wouldn't hurt my feelings. But this is the way that I've done it, so this is the way that I'm going to do it. And so, of course, in order for this to work, we need to have some kind of an action. And so the action will be receiving the barcode. Remember, we don't want to go out and grab an item from a barcode scanner. What we want is for the outside world to send us a barcode. So we've said that we were going to model this as an incoming event. But an incoming event on what? Some kind of object. Now, what would you call the object that we use to sell an item? Well, I can't think of a better name, so let's try sale. So sale on barcode, the standard naming convention for an event. And let's just choose an actual barcode. Now, in order to write this test, we have to choose concrete values, even though those values right now don't really mean anything. But in here, let's assume for the moment that 1, 2, 3, 4, 5 should match $7.95. This is a simple action and assertion. There's no arranging here yet. We haven't created the objects that we need. Well, let's create those. First, let's import assert equals. And then we need some kind of display object. And I'm not sure what to call it, so why don't we just make it a display? And let's move this up here. And our sale, we need some kind of a sale object, so let's call the class sale. I don't really have a better idea than this so far. And so now we've at least got the objects ready to arrange. So let's generate those classes. Now, just to make it a little bit easier to follow along, I'm going to make an inner class here called display, except I'm going to make it public static. It's always better. I don't want these classes to be able to depend on an instance of the test. So I'm at least going to make them public and static. Public's not strictly speaking needed right now, but I'm going to do it anyway. Let's do the same thing with sale. And now we can generate our methods. So there's onBarCode, which takes a barcode and returns nothing, because remember, event handlers don't return values. It's fire and forget. That's the whole point of the design of an event handler. And we need a getText method. And of course, this needs a return, so we'll just use the default generated return. So now our test compiles, we can run it and watch it fail. Very straightforward test so far. And of course, how are we going to make it pass? Fake it till you make it. All right, so we can sell any item as long as it costs $7.95, which is the way I like to think of it, right? If every product in our catalog were if this were the $7.95 store, then we'd be done. Because we just assume that the price of everything is $7.95 and everything is cool. But of course, that's not going to be good enough. We're going to need to do more. And so the first technique that we can use to force ourselves to generalize this algorithm a bit is called triangulation. Triangulation is something I learned from Kent Beck's Test-Driven Development by Example. And the idea of triangulation is use multiple data points in order to force me to write a more generalized algorithm. It's just like triangulating a signal in space, right? If I want to locate the source of a signal in 3 dimensions, then I just need to fix on 4 different locations, and that's enough to narrow us down to a single point in 3 dimensions. Well, it's kind of the same thing that happens in code. If a particular algorithm has 7 or 8 or 9 degrees of freedom, you could think of them as code paths. If I have 9 of them, then I probably need at least 10 tests in order to fix myself to that particular 9-dimensional algorithm. Well, this algorithm is going to be a little bit more straightforward, but it's certainly more than 0 dimensions. A 0-dimensional algorithm is like this one, return a constant. So to force myself at least to introduce a variable, I need another test, which means perhaps I need a test for another product found. This will at least force me to consider more than one possible price. So we have a new price, and that only makes sense if we have a different barcode. And for that, we need our same objects. And that test compiles. Let's watch it fail. Expected $12.50, but was $7.95. And so now how do we go from $7.95 to $12.50? Well, the technique that I like to use is to move the output closer to the input. The input is what I need. If we just look at these 2 tests, we can see that the decision of the price seems to depend on the barcode, which makes perfect sense. Intuitively, that's how this works. Different barcodes, potentially different prices. And so in order to make the output a function of the input, we need to move the output closer to the input. Now, I don't like to refactor on a red bar. I like to refactor on green. So I'm going to back out our second test while we do a little refactoring. And we're going to move the output closer to the input. So right now we have, this is the little icon for a test being ignored. It'd be nicer if perhaps we had a yellow bar or something, but at any rate. So in order to move the output closer to the input, I want to move this $7.95 into the onBarCode function. That way, onBarCode can decide whether it should be $7.95 or $12.50 depending on the barcode coming in. That means that we need sale to have a connection to the display so that the sale can tell the display what to display. Well, let's see how that would work. Let's move backwards. Let's introduce this as a field, and we'll leave it in the display class, and we'll call it text. And in order to be able to set that text, we need to be, so let's just make sure that test still passes. Nothing as much has changed, so it still should. We need to be able to write this, so let's do that. Encapsulate fields is what I want, and so there we are. That should still pass because nobody's using set text yet. And now, if I ask my display set text 795, whoops. No, I want that as a field. So let's create the field. And let's initialize this as in the constructor. Sale takes a display, yes. And so now you can see already in the tests that sale now takes a display. Test should still pass. Now right now we're setting the text at 795 in the display, then or in the sale, then throwing that away when we call get. So now if I remove this, the test should still pass. And it does. So taking a look now, we can see that now the sale is the one deciding whether to display 795 or not. And now the output is right next to the input, which makes it possible for us to connect those two together with the next test. So now sale decides to display the price, which means now we can put this test back and watch it fail. And now in our test we can say, or in our sale we can say, if 1, 2, 3, 4, 5 equals barcode, then do the old thing. Otherwise, do the new thing. And the test should pass. All right. Now what happens, you can start to get a sense of what happens now if we added, say, a third product and a fourth product and a fifth product. We could triangulate. If I didn't already sense what the pattern was, then I would add a third test for yet another product found, 3, 4, 5, 6, with a price of $25, and that would force me to write something that kind of looked like this. With some other stuff. And in fact, I'm going to leave the else if there just to make it even clearer what's happening. So here, let's see, clarified some duplication in the code. Clarified some duplication. Whenever I'm looking to remove duplication, which is the basic two-step process of test-driven development that we've been using so far, one of the tools in my toolbox is making the duplication more explicit, clearer. By adding this else if, I haven't changed the behavior of our code in a meaningful way, in a significant way, but I've made the duplication between these two pairs of lines much clearer. Now, of course, that last change did change the behavior of the code. It used to be the case that one barcode is $7.95 and every other barcode in the world is $12.50. But remember, I said that it didn't change the code in a significant way, and the significance comes from the set of tests we've written so far. I only care about the price for barcode 1, 2, 3, 4, 5 and barcode 2, 3, 4, 5, 6, and I haven't changed that behavior. So generally speaking, when I talk about significant behavior, I mean the set of behavior defined by, or the behavior defined by the set of tests that we've written so far. And so I think it would be pretty obvious that if we added more special cases, we would just have more of these else if branches. And certainly we don't want to do that. We're starting to get to the point where it's, you know, if I added a third and a fourth and a fifth one, it would get ridiculous. I kind of get the idea. So what I see here is the emergence of a lookup table. So over here on my test list, I can write down that I want to let's see, introduce lookup table. And that's something that's going to come out in just a little bit. But for now, let's run the tests again, make sure they pass. I'm pretty sure we're checked in. Absolutely, everything's good. So now, before I refactor, I don't want to refactor too early. Let's consider the case where the product is not found, which is the other interesting, particularly interesting case here. So what I'd like to see is something like product not found for 99999, which is the barcode. So I just sort of put my customer's hat on and said, this is the behavior I'd like. And of course, that will happen if the barcode is 99999. And for that, I'll definitely want my display and sale objects again. Let's run the test and watch it fail. Expected product not found for 99999, but was null. Excellent. So now let's just copy this over. Watch this pass. And let's commit that quickly. So we can handle not finding a product, but only if its barcode is 99999. The nice thing about writing commit comments this way is by writing the but only if blah, 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 I'm making it really clear what assumption I'm making in my tests, and that gives me an idea of what assumption I want to break in an upcoming test. And so one of the things that I definitely want to do is remove this reliance or this assumption that the barcode for the product I didn't find is 99999. Because certainly right now, if I were to change the input in our test to 88888, the test will still pass. Now the test is wrong because the test should expect product not found for 88888, and that would fail. But this is just a quick way of showing, verifying the assumption. I've already sketched out the test that I want to write that would allow me to get rid of the assumption I'm making. But I'm actually going to do this a different way. So the technique that I showed you earlier was triangulation, where you add more tests with different inputs, different expected outputs, and that forces me to generalize the algorithm. And the idea is that each data point forces me to nudge the algorithm in the direction it needs to go. There's another way to do it, and that is to remove duplication. There's duplication in hard-coded data between the test and the production code. And whenever I have duplicate data between the test and the production code, I want to move one copy of that data towards the other. And the direction I want to move it is from the production code out towards the tests. Whenever we have duplicate data, and that could be input data, it could be configuration data, it could be copying and pasting what amounts to really global data or implicit data. Whenever we have that between tests and production code, as I said, we want to move the production code version out towards the tests. In general, we want to move the server copy out towards the client. The idea here is that generalizations should move out towards the client, and abstractions should move down towards the server. This has many different names. It's known as the dependency inversion principle. It's known in the book Pragmatic Programmer as abstractions in code, details, and data. It's related to the open-closed principle, because the more abstractions deeper in the system, the fewer details that are deeper in the system, I should say, the easier it is to close that part of the system for change, but instead change its behavior simply by changing configuration data or input data. But the general idea here is to move details up the call stack and move abstractions down the call stack. That's one of the general underlying principles that I use to guide where do I move things when I see duplication. It's not enough just to remove duplication and have that be your guide. You want to have some idea of where the duplication should go. So all that's a long way of saying let's move the duplicate data from the production code out towards the tests. So this 99999 in here in the production code duplicates the 99999 out here in the test. Now the nice thing is that this 99999 is the barcode, and the barcode is coming from the tests, from the client. So this is a relatively easy change to make. First, I'll just do that and run the tests. I know it seems ridiculous to run the tests now, but it can't hurt and it only takes a few seconds. Let's replace this with barcode, make sure that works. Excellent. Reformat the code. Well, it happened to be formatted correctly, surprisingly. And now, I think that's it. I think that we've removed the duplication. 99999 is no longer hard-coded in our production code. So let me just check that in so we can handle any missing product barcode. Now, if you mechanically and blindly remove every bit of duplication you see in hard-coded data between production code and tests, eventually you're going to remove duplication that you wish you hadn't. That's okay. There are ways to check that, and I'm going to show you one in just a moment. Just be aware that removing duplication between the production code and the tests is a shortcut. Triangulation will always work. And so if you're not 100% sure whether removing the duplication between production code and tests is going to work this time, you can always fall back on triangulation. But that doesn't mean don't try to push the envelope. You never know what you'll learn. And we can show that by now doing a little defect injection. This test should now fail. Expected 9999, but was 8888. Perfect. Let's put it back the way it was. And now over on our test list, we can scratch out both product found and product not found. And then we'll have to think about empty barcode and null, which we'll do in our next episode. So thanks very much for watching. Hope you enjoyed it, and we'll see you again next time.